So let me tell you a little bit about myself. I'm Timothy Hobbs. I study at the Charles University in Prague. I study pedagogy, which is education. You can see here, or maybe you can see here, how I use my computer. I have it hanging above my bed, and I can see the screen because the screen is hanging above my bed, and then I use a normal keyboard. So if you can't see, what you will see is a set of wooden beams constructed above my bed, and some clothesline which has been tied into a net, and it's holding my laptop above my bed so that the screen is visible to me. And then there's a keyboard, a normal computer keyboard, on the bed as well. So today I'm going to tell you about a proof of concept type prototype for a refreshable mechanical Braille display. I'm not going to make any patents on this. My main goal is to reduce the cost of these mechanical refreshable Braille displays. They're the displays that plug into your computer. So what's displayed on the screen right now is a block of wood with some things screwed into it, and then actually a shower mat that has a kind of grid in it, and that grid holds up a piece of cloth, and on that cloth are 6 beads which have been sewn onto that cloth. This cloth is a lycra cloth. It's stretchy, and if we look down, I don't think this is visible even to sighted people because I don't have a perfect camera, but there are strings hanging down from the cloth, and when I pull one of these strings, the bead gets pulled down, and this means that when you display Braille, normally all 6 dots are raised, and when one of the strings gets pulled, that dot gets lowered. I chose this concept because I was originally working on a slightly different model for mechanical refreshable Braille. I wanted to use cams, which are little wheels that are flat on one side, to raise and lower dot bars. And the problem is when you use this system, the dot bars can get stuck, or if there's dust in the system, it becomes unreliable. And there's a certain amount of friction involved if you want to make the dot bars aligned properly. So I wanted to change the way, I wanted to find a more reliable system of raising and lowering dots, and I came up with this lycra cloth system, and it seems to work relatively well. I think that actually using springs to hold the dots up, and then using springs to hold the dots up and strings to pull the dots down might work better, but I don't have access as a private individual to very small springs. I haven't been able to figure out where in Prague to buy that to build a prototype. I also don't have the ability to mold custom plastic parts, and I would need to create a relatively complicated and small part to hold those springs in alignment, so I haven't been able to prototype that idea. One of the things that's nice about this lycra system is that here, above the lycra cloth are a whole bunch of bits of string that are tying the beads on. We could cut those, of course. There's also a pin that holds the dots apart so that when you pull down one string, the other beads don't get pulled down. Because if you don't have this pin stuck through the cloth, when you pull down a dot in the middle, the two dots on the other sides get pulled down. So you end up having a little bit of or infrastructure involved. But if you fold the lycra cloth over, so there's a layer of lycra cloth on top, you can't see the beads anymore. But if you put your finger on them, you can feel them through the cloth. So, and this is actually really nice. If I read Braille personally, and when you're just rubbing your finger along a piece of cloth, it's very comfortable to read. Whereas if you're rubbing your finger along a piece of lycra cloth and you come across some beads, it's like you're completely you're constantly coming into something that has a different amount of friction. And also, if you don't fold the cloth over and you come across the bead can get pulled by your finger, especially if you have somewhat sticky fingers. I don't know, my fingers are somewhat sticky even though I wash them. So I find that folding the cloth over really helps. So now, hopefully I'll be able to demonstrate my next step in this. I have these little bars, as you can see, and these bars have the purpose. This bar has a little arm on it that can push a string down, and this bar is a locking arm. So what we'll do, if I can set my camera up, right? What we'll do is we'll take this arm that pushes a string down here, and then push the locking arm, and then here I actually have to use my fingers to align this, but now I can feel that the middle dot, which that string correlates to, is pulled down. And when I pull this locking arm out, that bead or dot immediately springs back up because the lycra fabric is springy. So I'm hoping that I can set up two stepping motors. One to push this bar forward and push down a string, and the other to push the locking arm forward and backwards. And this would allow me to push down certain strings and not push down others. And I believe that a stepping motor costs about $5. And I believe I would be able to set up these dots in a column so that each stepping motor or each pair of stepping motors correlated to a significant number of Braille cells. What I haven't yet been able to determine is how fast this would be able to refresh. What I have been able to determine is that this would allow for multi-line displays. But at $5 for one stepping motor, one of the things is that you do not need, for each column, you do not need a separate stepping motor for the locking arm, because the locking arm is going to progress at a constant rate, whether you're pulling down a string or not. It's always going to progress forward. So you need one stepping arm to push, or one stepping motor to push forward this locking arm, and then one stepping motor per column. So that gives you a material cost. The cost of the glass beads is negligible. The cost of the string is negligible. And the cost of the lycra cloth is negligible. So you're going to be looking at about $5 per column in material costs if you can get the stepping motors for $5. I'm not sure how much for the stepping arms. So probably say $7 per column, which for the materials. And then manufacturing is going to be a significant cost as well. But I think that's at least significantly cheaper than what the current piezoelectric displays cost. So that's my proof of concept prototype. As I said, there's still the big problem of how fast this could refresh. But if you have each dot, there's another issue too. This Braille cell right here is 1.5 centimeters tall, and it has 6 dots. It does not have 8 dots like on a standard computer Braille display. And I tried making a standard size Braille cell, and I found that put the beads too close together, and it was just impossible to do. And I didn't even think that with some kind of more precise manufacturing technique, I would have been able to fix that, because the Lycra cloth has a certain area that gets pulled down when you pull down a bead, and that area does not get smaller with better manufacturing. So this is a 1.5 centimeter tall Braille cell, which is fine for me. I have when you read Braille, there's 3 regions on your finger. There's the top region, the middle region, which is basically where the little, if you look at your finger, it has a curve at the end, and then a flat area here, and then another curve. And you have to be able to fit the Braille character within those 3 regions, because you're going to be determining which dot you're feeling based off of which region of your finger it's in. And if you have the Braille dot too tall, you would have to rotate your finger like this, and that would just become very slow to read. Right now, you read like this, and you don't want to be reading like this, rotating your finger with each character. So I'm not sure if like women or people with smaller fingers would have trouble with this or not. I don't have the ability to go and test this on a whole bunch of people because, as I said, I'm a private individual. So I guess that's it. The next major hurdle is, well, for me, the hurdle is always that I don't have, as a private individual, the ability to do precise manufacturing. Everything here was made with household tools. I used this tool to, it's a pair of pliers to cut a coat hanger for the bars that are mechanical bars. I used an electric drill and a clamp to drill the holes in the wood, and I used a sewing needle to sew the beads onto the cloth. So I really did not use any specialized tools in this. And I don't have access to any specialized tools. So I can't do any precise manufacturing in my prototyping, and I'm not sure how I'm going to progress onto the point where I am adding in the stepping motors and actually testing whether this can be hooked up to a computer and used as a refreshable Braille display. So far, it's just a proof of concept. This could work, I can tell you that. There is still the problem of the speed, the refresh rate. This is a complete unknown to me. So, thank you for watching, and goodbye.